4.1, chain rule part 2. So we're continuing talking about the chain rule, and we're going to look at one type of example here, two different variations of it. But so let's just get started. This example, what we want to do is we want to show the slope of every tangent line is positive in the following function here. It is y equals 1 over 1 minus 2x cubed. There's our function. And so you can see that it is a chain rule question because I have a function inside of another function. So I have 1 minus 2x to the third, that it would be my inside piece, right, to the third power. So let's take the derivative, dy dx. This is a quotient rule. You could change this to a negative exponent and it will still work out, although for our purposes, you'll see in a second, it's going to be helpful to think of, to analyze it in its fraction form. So let me show you what I mean. So we'll take the bottom, 1 minus 2x to the third power, times the derivative of the top, well, that's just 0, so that'll be nice later, minus the top, it's 1, times the derivative of the bottom. Derivative of the bottom is going to be a chain rule. So I'll take the 3 out in front, I'll leave the inside alone, 1 minus 2x, subtract 1 from the power, that's 3, times by the derivative of the inside. The derivative of the inside is negative 2, right? Derivative of 1 is 0. Derivative of negative 2x is negative 2. Okay, this is all divided by the bottom squared. So I have 1 minus 2x, 1 minus 2x to the third squared. Clean up. Okay, so we need to make that look a lot nicer because our goal here is to show that the slope of every tangent line is positive. Maybe we should take a second to understand what that means first. If the slope of every tangent line is positive, then we would need to show that the derivative is always positive. So that's what we're aiming for. So in this format, showing that the derivative is always positive, I don't know about you, but it's pretty difficult for me. So what we're going to do is simplify and hope that it gets a little bit easier to analyze. So this is just 0 here. This will be negative 3 times negative 2. So that'll be a positive 2. So I'll have a positive 2 times 1 minus 2x. And I forgot to subtract 1 from the power. Sorry, that should be the second power. My bad. Make sure you make that correction. Okay. So positive 2 times 3, that should be a positive 6. Darn it, 2 mistakes. So positive 6. Okay. Great. Okay, all of that is divided by power to a power we multiply, so I end up with this. 1 minus 2x to the 6th power. Okay. So now we ask ourselves, can I show at this point that this function is always positive? And we can. You might notice that I've got 1 minus 2x squared and 1 minus 2x to the 6th here, so these will simplify. But that doesn't really matter because I can look at this and be like, all right, well, the numerator is always greater than 0 because it's positive 6 times something squared. Something squared is always positive. So that's got to be greater than 0. This thing is the denominator is to the 6th power. That's always greater than 0. So since both of those are always positive, then the slopes of all of the tangent lines have to also be positive, okay? And you should write that out in, a sentence or something. But yeah, so based on that, we've justified that all of the that all the tangent lines must be positive. I'm going to do one more. You should try this one and see how you do by playing the video through. So we've got this, f of x is equal to x over square root of 1 plus x squared. Like I said, give it a try. Pause the video. Try it. Hopefully you paused. We're going to look at f prime of x and we're going to see how this goes. First of all, I'm going to change this. I'm going to change this to 1 plus x squared to the 1/2. If you were completely stumped and you didn't change it, you might change it now and try it. I'm going to take the top. I'm going to take the bottom. Good job, Cresswell. Boy, you are killing it today. I'm going to take the bottom times the derivative of the top. So I'll go 1 plus x squared to the 1/2 times the derivative of the top, that's just 1, so we're good there, minus the top times the derivative of the bottom. Okay, so derivative of the bottom will be 1/2, leave the inside alone, subtract 1 from the power, times by the derivative of the inside, which is 2x, like that, okay, all divided by the denominator squared. So that is 1 plus x squared to the 1/2 squared. Well, that's a mess, and it's pretty difficult to see whether this is going to be positive or not, so let's clean this up a little bit. Now I'm actually going to switch to roots, because knowing, for instance, that 1 plus x squared, knowing that it's a square root, is going to give me some information. That always has to be positive, right? You can't have a square root output a negative number, so that piece is always going to be positive. Here, I'm going to have minus 2, so hold on, we have 2 times 1/2, that's just 1. X times x is x squared, so I have minus x squared times 1 plus x squared to the negative 1/2. We'll deal with that in a minute. And then underneath here I have 1 plus x squared, right? Because square root is something squared, so I have 1 plus x squared. So right here I can see that the denominator is always 0, so that's fantastic. I just need to show that the numerator is always 0 as well. Okay, and to do that, there's no good way to do this. I don't think so. I'll take square root of 1 plus x squared minus, and this is the same as x squared over the square root of 1 plus x squared divided by 1 plus x squared. I'm going to do a common denominator, and so this one has a denominator of 1. It needs a denominator of root 1 plus x squared. So what I'll end up doing here is taking and multiplying this by root 1 plus x squared over root 1 plus x squared. So on top, I'll just get 1 plus x squared. On the bottom, I will get square root of 1 plus x squared minus x squared over the square root of 1 plus x squared, all divided by 1 plus x squared. Combine the fractions. So let's reorganize this a little bit so you can still see what we're doing, what I'm doing. Okay, so on top, I'm going to combine these two fractions together. So I will get 1 plus x squared minus x squared divided by the square root of 1 plus x squared, all divided by 1 plus x squared. Things are coming together nicely here. This is going to be 0. So I will end up with this. 1 divided by the square root of 1 plus x squared divided by 1 plus x squared. Let's check this out. 1 is always positive. Root of 1 plus x squared is always positive. Denominator 1 plus x squared is always positive. So I always have positive numbers. So this must always, so we can write this, dy dx must always be positive. All right, and I think that's a good problem to end this section on. A lot of algebra 2 stuff in there, a lot of pre-calc stuff. That problem really ties in an understanding of functions. Everything kind of ties in together on that last problem. So I think that's it for section 4.1.